Hello everyone, this is David Klee, founder and chief architect of HeroFlux Technologies. Thank you for watching this session, 10 cloudy questions to ask before migrating your SQL Server. I appreciate you more than you know, and let's get started. First of all, you're here because of PaaS. This is a fantastic conference. The PaaS organization is worldwide, has a lot of fantastic members, and tons of great information. So go check it out over at paas.org. If you already haven't, just go do it. There's so much good information over there. I think I can speak for all the presenters out there by saying that we all want to be better presenters and speakers. So if you do have feedback for us, constructive feedback on any of the sessions that you see, mine included, please give constructive feedback. We do want to know if there's something we can do better, if there's something you think that was incorrect, let us know. Please submit before Friday, November 20th at 5 p.m. Eastern Standard Time to win some prizes. My name is David Klee. I am the founder and chief architect of HeroFlux Technologies. You can find me at my contact info on the screen there. Those are probably the easiest ways to get in touch with me. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert, and I spend my days consulting around performance tuning and high availability and disaster recovery for both the database layer and the cloud and virtualization layer that it runs on. Our agenda for today is pretty straightforward. We're going to tackle the top 10 questions that you need to ask when you are considering migrating your enterprise databases to the cloud. Question number 0. So we make sure we're all on the same page. What is the cloud? First of all, the way I like to look at it, there is no cloud. As the sticker here says, it's just someone else's computer. That is exactly right. My definition of the public cloud is that it really is somebody else's data center with really good virtualization and even better automation. It becomes a self-service platform that you deploy, you manage it, you use it the way you want, and you can turn around and deploy the different applications as a service or virtual machines or any other construct that they make available to you. And you can use this to boost your IT operations and pay for this on a monthly basis as charged all the way down to the second that it's up and running and in use. Let's get some of these definitions out under us so that way we're all on the same page going forward. Infrastructure as a service, or IaaS, is essentially a virtual machine out in the cloud. You provision the scale, you manage the disks underneath to give you the configuration and the capacity that you want, and then you can deploy your own applications in it or buy the virtual machine with certain applications like SQL Server pre-configured in it. There's platform as a service, or PaaS, and the way I look at this is a managed instance, or Amazon RDS. This is the SQL Server environment, but you just don't have access to the underlying operating system. It's almost feature complete with a regular SQL Server. There's a handful of things that because it's dependent on the operating system you don't get, but most of the time that's perfectly fine. Now we can get in the habit of building out the SQL Server here in a managed instance and starting to just use it, but we don't have to worry about availability. Now, if we have a simple task, Database as a Service, or DBaaS, because I love all the TLAs here, it's essentially Azure SQL Database, and it really is nothing more than a database. We can use this, we don't get the agent, we don't have the operating system, we don't even get the instance to go in and configure. But do we need it? Probably not. You got to choose your words carefully here because the different services might have different meanings to different people, but this is my definition of these things. A common question is, where is the cloud? And quite frankly, it's not in the cloud, it's on land. If you look at the different cloud providers out there, they all provide a regions map. And you can start to see where the different groups of data centers that the different cloud providers are located at, you now have the ability to pick and choose a data center that corresponds to your needs. Maybe you want it very close to you personally. So for me, that would be Central US. You may want it farther away for disaster recovery. Maybe get it on one of the coasts or push it just away from me, and that way I'm geographically separated. The biggest thing, it's physical. It's a physical location, but you can pick where these things are at. Now, there's a lot of big major cloud players. My personal preference is the Microsoft Azure platform. You may see a lot of people talking up this platform at the conference, and that's great. I'm all for it. I like it because they write the code that I deal with every single day. Therefore, I get all the bells and whistles there sooner. But that's not to discredit the other platform. Amazon Web Services, Google Cloud, Alibaba, they all have fantastic services. They all serve the needs of a lot of these different tasks. They all work. I will say that if you're looking for cloud services from a smaller entity like a regional co-location or data center group, you might be surprised at the economies of scale and the decreased prices that you get on these cloud providers. One of the biggest things that they offer is because they're so large and so complicated and advanced in good ways, they're able to offer you a lower price simply because of economics. The regional vendors are great for what they do. It's good to have people nearby that you can go talk to when you need something. But at the same time, watch your costs because these folks here offer more services at more competitive prices. Question number 1. Why are you considering moving to the cloud? Cloud! Yeah! Woo! Now! Drop everything! We're all in! Go, 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 go! Hey, okay, there's a problem here. The biggest single challenge that I see is when a company makes a decision to go to the cloud, it's go, 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 go. We have to get there right now. And that is a big challenge. So why move? Why really consider this major platform shift? I mean, it sounds crazy, but I've heard and seen many different examples where the CEO read about it on, a magazine or something, goes, okay, we got to do this. We're going. On-prem is a great solution when it's the right use case. So is the cloud. You have to be really smart about this. And it's not an all or nothing approach. You have to sit back and compare and contrast the different offerings that are out there to figure out what's right for you. Public cloud is a fantastic option when it's the right use case. So are regional colos. Maybe you've already got your equipment there. Maybe they offer things that you want and it's a lot less complex of a solution. Cloud services are great to use on a piecemeal basis. The good thing is none of these are mutually exclusive. You can start to use the different pieces how you see fit. The best part about this is all of these pieces have very good automation to help you do more of what you need to give that competitive advantage to your business without having to get in the way of you micromanaging these things. To me, it always goes back to the competitive advantage. And I know this is going to sound really pessimistic of me to say this, but the business doesn't necessarily care about the platform that powers the business. They just need this stuff to actually run. So what can we do? What benefits do any of these solutions give the business to provide a competitive advantage over your competition? Does it bring that competitive advantage to make your life better? And this is a business call, not just the technology. What can going to the cloud, either the different solutions, the platforms, getting the data closer to the people, what can it do to bring you that advantage? You have to be able to quantify this. This is one of the single biggest areas that I focus in my consulting career. Most organizations, when they want to do something like this, it's a very subjective. We have to do this because it's great or it's the right thing. But quantifying these pieces is really difficult. What specific metrics can you use to make your life better? And then how is the business going to monetize this? What strategic advantages will generate either cost reductions or improved revenue or making staff more efficient or all the above? It's not just a technology change. Cloud is not all IT driven. It has to come from within. The business has to be aligned. This is a new way to do operations in IT. The business has to be on board with this. Cloud is a means. It is not an end. And I should get that tattooed on my arm or something. Cloud is the platform. Cloud is automation. Cloud is a lot of things. It's not an end game. It's how can you use this thing better to embrace better change? How can you systematically measure the value that you're getting by going to the cloud? And again, it's not a one-time thing. You have to continuously do this. The other big thing here is platform modernization. If your business is changing, if it's growing, if it's scaling more from a regional impact to a national aspect, how can you start to leverage the cloud to modernize a data platform to not only set yourself up for future growth and change, but to take advantage of this? The last big thing here is platform modernization. A lot of legacy database systems are very stuck in some older ways to do things, and it could be inefficient operations. It could be a lot of manual operations. It could be holding the business back, especially as businesses change, especially this year. How can we take advantage of the cloud to change and improve a lot of these practices and processes to leverage the different features in the cloud? How can we make things better? And by better, make it faster, make it cheaper, make it finish quicker, get the data closer to the end users, put the data in the hands of your business users to provide business value by mining this data. What can you do to improve business by leveraging the cloud? Now, there are a significant amount of myths associated with the cloud itself. A lot of people think it is an all or nothing approach, and I'll be the first to tell you it is not. There are thousands of different things out in the cloud that you can leverage. All of them are mutually exclusive, and you can pick and choose how you want to use these different things. A lot of people think cloud is cheaper, and a lot of the marketing out there says cloud is cheaper. Quite frankly, a lot of the pieces out in the cloud are not cheaper until you start to factor in the implicit cost. Power, cooling, staff time to manage these different pieces, and not just talking about the stuff that's got to be micromanaged in the cloud or on-prem, wherever you're at. You have to be able to quantify this, though. I love the phrase, it's better. It's like, yeah, but how can you measure this? How can you put numbers and metrics to gauge against with this? A lot of people also think that the cloud does not require any maintenance. Well, some of the pieces in the cloud you don't have access to, so you can't go maintain them. But other pieces certainly do. And nothing is foolproof, nothing is bulletproof. You do have to properly maintain this stuff. You just have to adapt to what you do or don't have access to. A lot of people think it's easy. Well, no, it's different, but it's not easy. It's just different. Some things are improved, some things are not. Other people think it makes things faster. This is another one of those subjective areas. I'm sorry to say, if you're coming from a mega environment on-prem and looking at cloud, well, it probably isn't going to be faster. Conversely, if you're coming from an on-prem environment that's 10 years old, that was slow when you bought it, and it's even slower now, yeah, it's going to be faster. So it's very subjective. Where are you coming from? Where are you going? What are you doing with it? And quite frankly, what if the bottleneck's not on the platform? What if it's on the code or the processes, things like that? Well, it's kind of like putting lipstick on a pig. A lot of people also think that the cloud is guaranteed available, and I'm sorry, but there are SLAs published in the cloud with every single cloud service, and you might be surprised at how low some of these are. You might also find out that at the end of the year, it might actually be worse SLAs than what you're coming from. You got to be careful. And then the whole FOMO thing, everyone's doing it, fear of missing out. Well, I'm sorry, but not everybody is going to the cloud directly. Not everybody's all in. It's all in how you want to use it. There's a lot of myths around the cloud. There are also a lot of facts around the cloud. The cloud is extremely flexible. It is as flexible as you make it. The automation in the cloud is so significant and so amazing that it is as flexible as you want to leverage a given service or a task or a tool, things like that. I would argue the cloud is more secure than your on-prem environment. A lot of people don't think this, but have you looked at your security on-prem? The odds are things are wide open. In the cloud, they're locked down by default. You have to unlock things just to be able to get in and start using it. So a lot of times, the cloud is more inherently secure out of the box than your on-prem environment. There are other methods inside the cloud for platform modernization. Some are complex, some require rewriting a lot of your processes, but others are pretty straightforward. Managed instance is one of them. A nice, easy migration, and away you go. I can argue with the biggest and the smallest shops out there that cloud is going to do a given task faster than what you can do on-prem right now. Because of the end user portals that are present in the cloud, most of the time we find that when an organization needs to do something in IT, that speed of the operation is really held back by the people and the processes in your IT department right now. When you're in the cloud, that challenge doesn't exist. It's you script it, you click it, boom, it's up and running in minutes. Usually we find that IT in the cloud can move at the speed of business, where on-prem, it's probably getting held back. Scalability is another big one. Now, this is all subject to how you need to use this. But if you're in the cloud, They've got tons of resources there at your disposal. If you need to ramp something up from 2 CPUs to 64 or even beyond, well, yeah, get out your credit card, click a couple of times, and boom, it's that big. A lot of times, if we need more horsepower in our own data center, we've got to go through an acquisition process, we've got to get the equipment in, we've got to plug it in, cable it, rack it, burn it in, and then we can maybe start to use it, in as short as a couple of weeks. But what if you need something right now? The scalability that's built into the cloud is one of those things that it's really hard to compete with on-prem. I mentioned it before, I'll say it again. The automation effort in the cloud is one of those things that I have never encountered an on-prem organization that even came close to the amount of automation power that's in the cloud. Do you need all of that? Remains to be seen. But the automation capabilities are there, spinning up databases, automating certain tasks, integration of certain things, being able to sift through dissimilar data in a data lake. I mean, there's just tons of good functionality out there that's all automated and all easy to deploy and manage. Staff time efficiency is another one. A lot of people take this one for granted, but there's a lot of maintenance that goes into the feeding and the care of an on-prem, either physical or virtual platform. There's hardware drivers that have to be updated, there's operating system level patches, there's firmware updates for the physical machine, equipment dies and you got to go deal with this. All of these things are time spent away from being proactive to help make sure the environment is running as good as it can possibly be and to make sure that it's highly available, well-tuned, high-performing, that sort of thing. Those tasks disappear or get minimized in the cloud. There's still maintenance that's got to be done there, but a lot of times we can make our staff more efficient with the bare maintenance of the platform, and it frees up some of their time to be more proactive for you. It's not going to replace any jobs, but it's certainly going to make people more efficient when it comes to managing these platforms. The financial model shift is one of the biggest ones. In an on-prem environment, most of the time what people do is they will buy equipment, every 4 or 5 years. It's not all at once, but it's all trickled in over time. And then they'll buy the hardware up front, they'll run it into the ground over the next 4 or 5 years, and then eventually, they write it off the books, they may move it to DR, they may sell it, they may give it away, whatever they need to do with it. But it's a capital expenditure that's up front every so often. The changes in the cloud are big in this area. Instead of buying this up front and then running it down over time on the books, this is now a monthly purchase for either what you allocate or what you consume. And that model is different. It's way different. And a lot of organizations love it and other organizations hate it. The last fact here is unless you are a large organization that is running a data center or a colo, chances are you're not in the data center business. And this is probably the biggest thing that I see that organizations are shifting away from. In the past, they had to maintain some kind of server footprint in order to power the equipment that makes their business operate. Now you can go to the cloud. You don't have to deal with having your in-house data center and power and cool and highly available and disaster recovery and all these other pieces. And plus the staff time to manage this. Now, you can say, give me a data center out there somewhere, and I'm just going to use it. Question number 2, how do you want to use the cloud? The cloud has got so many use cases that quite frankly, I could spend the next 2 months sitting here rattling them off, and I don't want to bore anybody with that. The biggest things for me is it is not an all or nothing approach. It is not always all in. You can strategically use these different components based on what you need at the time and what you project in the future. But define the strategy before your migrations start. And this is why I stress we have to understand what the cloud can actually do for us and how are we using our systems on-prem to figure out what use cases we actually need in the cloud, if any, and how we need to leverage these things. I do find that there are a number of buckets that I find organizations usually kind of self-group into, especially lately. The first, a lot of organizations are just starting to test the waters with the cloud. They may not be too comfortable with it. They may not have a large IT group, so making this change is pretty significant. So they're starting small. They're starting with offsite storage for backups, and it's great. Whereas a lot of these organizations, no joke, would either replicate to a NAS at another location, or some of them would actually just pack up yesterday's backups onto a tape drive or a USB drive and throw it in the back of their car. That's not really good offsite storage. What you can get started with in the cloud is just simply replicating your backups up to one of the storage tiers in the cloud. Azure Blob works great. We do this ourselves. There's different tiers out there. There's hot, there's cool, there's archival tier. Depending on your use case, any or all of these are going to be suitable for what you want to do. This is one of the models where it is pay by what you consume. You pay by the gigabyte or megabyte here, and you pay for as long as it's sitting out there. Leveraging the cloud for disaster recovery is another one of those areas that we find organizations are really starting to jump into. For years, they've been taking staff time and equipment at a second or third location to have it up and running and receiving a constant stream of changing data and testing periodically, all while most of the time it's just sitting there being a pretty good and expensive space heater. Leveraging the cloud for disaster recovery is it's a fantastic way to really start to dive into this stuff. You can replicate your virtual machines, you can replicate your database backups to keep your RPO and your RTO down pretty low, and you can use this, replicate up around the clock, test it periodically, and it works. You can do a hot, warm, cool standby software as a service out there. It does work really, really well. It also means that you can keep your costs down. You don't have to maintain this equipment at a different location. It's usually cheaper. It's usually less complex. It works really, really well. Another area is if you have a business that has very interesting peaks in usage. Examples of this could be manufacturing plants that have a really big order that comes in, or e-commerce site that's spinning up before the holidays, or a performing arts center that's got a lot of different web servers that are about to go on sale with a really big show. All of these things, you may need burst scalability in your systems, and quite frankly, you may not want to pay all that much money to have these really big systems sitting there 99% of the time doing nothing. So you can use the cloud to scale out temporarily, and you can usually do it faster than your IT department really can. You can scale it outwards with the right application architecture, and then when you're done, scale it up, scale it back. It works really, really well for that sort of thing. Other organizations just want to use specific services. You can use one of the integration platforms out there to pull in data from different systems, process the data a whole lot faster than you could on-prem, and then pump the final stream back to you. You can use data lakes for different bits of integration out there. A lot of times, reporting and business intelligence workloads are a lot easier to manage in the cloud because, these are complicated systems, and now you just don't have to worry about setting them up and maintaining them in-house. There's also great examples with machine learning engines out there where you don't have to worry about setting them up, managing them, dealing with all the stuff that's around these complicated systems. You can literally just spin up an ML platform, use it, turn it off when you're done. Another way is if you have more of a scale out data and application architecture, you can start to scale this thing out and get the application and the data closer to your end users. We use Cosmos DB all the time to collect perfmon information. It's fantastic for this. I can scale out the data platform to different geos around the globe. It synchronizes eventually, and for that use case, it's fantastic. Or maybe, just maybe, you're all in. Are you done being your own data center management group? A lot of times, absolutely. Move everything out there. If it's the right tool for the job and the right use case, do it. But what do you need to do to move everything properly? That's the hard thing. And there's a lot of moving parts to this. Even basic questions like, how are your users and your applications going to connect to each other? These are very basic questions that have to be asked in order to really get this layer of the cloud migration understood, let alone implemented. One of the biggest and most exciting trends that I see in recent times is hybrid cloud. One of the biggest things that's always been missing is on-prem automation. We can build systems with scale, we can script certain things out, but to be able to say to a development group, here's a bucket of resources, go deploy what you need, we're going to make sure it's locked down by default. That layer of automation has just been sorely missing from pretty much every environment I've ever worked in. Microsoft Azure Arc, and there's some competitors out there from different companies from the cloud, but Azure Arc to me has the most compelling use case. It's literally all the automation in the Azure cloud, but now you can pick your own data center to deploy these things in. Or you can use the single control plane out there to deploy and manage these workloads in other public cloud providers. It's fantastic. That single management and telemetry interface is one of those things that it gives you a single pane of glass to be able to do anything that you need. If you're interested in it, azure.microsoft.com with the link down below, and it gives you the ability to go learn more. And it's up and coming. There's a lot of recent releases with this, but I absolutely love this. We've been exploring it. We're going to continue to do this. I think this has got the most potential out there because this gives you the ability to have that automation, but leverage your on-prem investment, use cloud services where it's most suited, and manage a multi-cloud workload appropriately in one management interface. I love it. Question number 3. What cloud database services do you need? In the cloud, you have got a lot of options for data services out there. When it comes to Microsoft SQL Server, there's the 3 big ones. Do you just need a simple database? You may have a simple application, a simple task. You don't need to manage the instance or anything fancy around it. You just need a database to use. Or do I need a single instance? Maybe I've got a couple databases that I need to move that talk to each other. Or maybe I've got certain agent jobs that I need to retain and I don't have the opportunity to retool these. Or maybe it's a third-party vended app that just won't support an Azure SQL database. Or maybe I need all of the features and all of the options and all the bells and whistles and all the patches and associated overhead of that operating system in order to migrate a given workload out there. And there are tons of use cases for this. A lot of legacy applications, a lot of third-party apps, a lot of things that are really complicated that we need to just lift and shift and get it out there because the on-prem equivalent is about to die, or a lot of different use cases. There's a lot of reasons why you might need just a regular SQL Server virtual machine. If you're just looking for a straight database, Azure SQL Database works great. It's literally just that, just a database. We use this ourselves for all kinds of things. You get a database, you get the tables, you get the T-SQL programming language, you've got all the big constructs that come along from a database development standpoint, but you just don't have to worry about the complexity of the instance or the underlying operating system. It really does work great. Now, availability and disaster recovery come along with the service. You get a highly available solution that is as available as the service tier that you go purchase. There's general purpose and business critical. Disaster recovery is up to you. You can elect to replicate this construct to a different location. And literally, it's as simple as picking on a map, picking a name, getting out your credit card, and hitting OK. Platform as a service, or PaaS, this is going to be Azure SQL Managed Instance, could be Amazon RDS. These are instances in the cloud. We don't have access to the underlying operating system, but for these systems, we don't really need it. We just want an instance to go use. It's really literally just an instance as a service. You're going to have as many databases on there as you need, up to roughly 100 or so. You do get agent jobs. You get a lot of the cross-database calls that might have been missing from the Azure SQL database side. You just don't get the operating system access. And to me, I'm fine with that. I have been patching operating systems for, 30-something years now. And quite frankly, I am tired of that. I just want to use this stuff. And with a managed instance, that's exactly what I can do. Now, availability and disaster recovery are very similar to databases as a service. You essentially click on the criticality tier, get out your credit card. If you need general purpose or business critical, this gives you improved SLAs as you get closer to the business critical side. For disaster recovery, you click on a map, get out your credit card again, call it good. Databases in the cloud in terms of virtual machines, it's basically SQL Server and a VM. I mean, this is full control. This is business as usual. We've been doing this for a long time. You patch it, you maintain it, you have to deal with the high availability of it. It's not the most fun, but quite frankly, if you have the need and the use case for this, it's there and it honestly works very fine. Disaster recovery gets a lot easier because now you can say, give me backups nightly in a backup vault, replicate this to another geo, potentially replicate the object to another geo, and that's basically it. It's a whole lot easier than managing another data center. I'll say it's easier most of the time. It always goes back to what do you need? And this is a loaded question because there is no one-size-fits-all answer for this topic. It's very situational. It's by application stack, it's by purpose, it's by need, it's by function. So if anybody tells you you have to go do this, I'm sorry, but nothing could be further from the truth. You have to understand the systems out there so you can figure out which one of these actually works for you. Do you have vendor requirements that are saying it's got to be in a virtual machine? Do they explicitly not support some of the other features out there? Understand the limitations of that choice. Understand the data portability side. Understand what it takes to get back out of it or migrate it to another tier. Understand the availability solution that they've got baked into it. Question number 4. What are your availability and disaster recovery requirements? I always say here, skip the technology, go to the business. There's 2 absolutely vital metrics that you have to define before you're able to go engineer your availability. First of all, what is your recovery point objective, or RPO? This is a very basic question. In the event that the poop hits the fan, how much data can we as a business afford to lose? Second one, what is your recovery time objective, or RTO? How long can this system be down before our business starts to either lose significant amount of money or customer trust or any of the objective metrics that you can say it is absolutely critical that we have to design for? This all goes down to the service level agreements that you have designed this system to meet or exceed. So let's just say that the business has decided that for your database system, your recovery point objective is 15 minutes and your recovery time objective is 1 hour. But maybe I didn't get the memo. I'm going to be fancy. I'm going to do transaction log backups every 30 minutes on the 15 and 45 minutes of each and every hour. I'm going to do this because there's always things that kick off on the hour and I just don't want to compete with them, right? Our last transaction log backup runs at 12:45 p.m. today, and 1:12 p.m. something happens on our storage array, and now we have to recover all of these systems, and these are real world examples. So now you scramble and you scramble and you scramble, and finally 3:55 p.m. everything is recovered, everything is back up and running. Business is back up, so now we can rest a little bit. But we got to figure out just how bad for the business was this. Between 12:45 and 1:12, that is your observed data loss. That's not good. The recovery window started the second you declared a disaster and is done the second the machine is back up and running. These are your recovery point and recovery time goals. 15 minutes for the RPO, 1 hour for the RTO. Well, bottom line, that design did not work for that outage. You just breached your SLAs both for RPO and RTO. In some organizations, that could be a resume generating event. In other organizations, that could have resulted in significant amount of data loss and money loss for the organization. That is not a good spot to be in. And this is why the recovery point objective and the recovery time objective have to be agreed upon by the business and understood at every layer of IT in order to make sure that these systems are designed to meet or exceed those numbers. Now, with your databases as a service, you get to pick the high availability that accompanies that tier of service. The SLAs are going to be listed at that cloud service provider for every service that you're interested in. Business critical tiers have improved SLAs, but whatever you do, understand the SLAs, and they're going to give you a number of 9s. Convert that to the number of minutes associated with that number of 9s, either on a per year basis or per month. Usually I see on a per month, because if things are rated at 3 9s or 99.9%, that can translate to hours a month. You don't get to pick and choose when those outages actually occur, and that could impact business for a pretty long stretch of time. If the SLAs on a given cloud service are not good enough, that provides a business case to request more budget to go up a tier of criticality, in this case general purpose up to business critical. Now this is why it's super important to go understand this. If your availability requirements are more stringent than the platform options for the tier that you've picked, It might mean that you have to either re-review that platform selection to figure out, do we really want to go with this service? Or is there something better that we can do? Or you may have to complement that platform's HA with your own. In some cases, that's fairly easy. In other cases, it's a lot easier said than done. If you're looking at just a SQL Server virtual machine, maybe it could be implementing an availability group between a few virtual machines. Improve your HA that way. If you're on a managed instance, it could be moving from a general purpose tier up to business critical so you get another number of nines improvement. Otherwise, it might be worth the time to talk to the business to reduce their expectations. If they want a really high availability but don't want to pay for it, it might be completely unreasonable, and you may have to try to walk them back from their expectations to something a little more grounded in reality. Your recovery point is very interesting. In a lot of these services, it's managed for you. With any of the cloud services that you decide to purchase, you have to understand the recovery point of that service with the features that they offer and how it relates to the backups and the recovery time that's going to take you to get up and running. These may vary depending on the service that you're buying into. In this case, Azure SQL Database, you get a point-in-time recovery going back a few days. The restore point, you can go down to the second, and that's awesome. Other times, in this case, let's say in Azure SQL Managed Instance, if you want a secondary tier to recover, you can back up a database over to Azure Blob with defined credentials and have a second copy of these that you can use not only to recover that machine, but potentially refresh another database on another machine. Please note, you can actually use emojis to name a database. Question number 5. What are your security requirements? This topic is always fascinating. What sort of data do you have? How absolutely critical is it? Are you under any sort of compliance? PCI, HIPAA, SOX, or a lot of the stuff lately is around GDPR? If you have any of the kind of data that is personal or sensitive or financial or healthcare, all of these things require, by law, and it doesn't matter what country you're in, there are laws all over the place for this stuff. It requires an extra sense of security and auditing to make sure that you comply with these regulations. The very first thing that I always ask is who needs access? There's a lot of challenges from a business perspective around this one basic question. But now when we're looking at the cloud, it's really interesting. It's a big shift from on-prem. Your practices on-prem are quite frankly poor. In most cases, things are wide open and then a handful of selected services are locked down. I've even seen healthcare organizations and financial organizations where things are just wide open, and it really frightens me. I claim that cloud is inherently more secure than most organizations' on-prem environment. And that's because it's locked down by default. You have to unlock it just to start to be able to use it. And by unlocking it, I mean, can you read the funny manual? And you know what I'm really going after here. You've all seen all of the cloud buckets and blob stores that are wide open and people stumble upon millions of important records out there. If you just read the manual on how to unlock this stuff, it flat out tells you, don't open this up to the world. Don't open it up and make it unsecure. People will find it. The perspective on this is always fascinating. On premises, like I mentioned, things are just wide open. There's no firewalls anywhere. All the servers can talk to each other. Cloud, it's so locked down that you can't even get to it until you start to punch holes in the firewalls. And this is one of those areas that as a DBA, you better get used to firewall technologies because you're going to have to learn how to poke holes in firewalls so these different pieces of applications can communicate with each other. Open up only what is required. If you open up any more than that, it becomes an absolute nightmare because things can find things. You really should have all this documented ahead of your cloud migration, or there are different features of different networking tools out there that can start to understand application dependencies, what's communicating with what, and you need to have this map well laid out before you go to the cloud, and that way you can lock this down to the absolute bare amount of communications that can basically stretch beyond a given machine. And in that documentation, you need to understand by server what talks to what ports, what protocols, what routes, all of these things. Have all of this mapped out ahead of time. This is one of the single biggest misunderstood and missed opportunities that drag on cloud migrations. Question number 6. How much performance do you need? The single biggest miss that I see in both on-prem and cloud environments is the need to have a good strategic baseline so you understand exactly what compute resources your servers are consuming. It's a really simple question. How much have they been allocated and how much of that is actually getting used? Third-party utilities can do this quite well. There's a lot from a lot of vendors. Hopefully they're all sponsoring this conference. But if you don't have the luxury of a budget that can get you these things, you do have Windows Perfmon. It's built into Windows. Now, this doesn't apply to SQL Server on Linux, but most of these are going to be running on Windows. Out at our website is a PDF and a video for how to set up Windows Perfmon the way we like it. There's no contact info required. We don't ask for anything. It's just a PDF and a couple of videos out there. But these are the things that you can use to set up Windows Perfmon on an ongoing basis to collect statistics with no performance penalty 24/7. And this is going to give you 30-second granularity for a lot of key critical metrics that will start to record what your systems are actually doing. Everybody on the internet says go collect Perfmon. What do they do with it? What can we do with that raw data that we've collected? Well, we released a PowerShell script out at GitHub over here, and that allows you to import this Perfmon data, BLG file output, binary log, directly into a SQL Server table, and that way you can get to that raw underlying data. You can start to figure out, is this something that we can work with? Can we get a baseline out of this? And now your favorite utilities like Power BI or Excel or T-SQL or any other tool that you want, you can now mine this data to get that raw information out and start to do something with it. Getting that raw data out is absolutely important, but it's a lot of data. Do we have raw key performance indicators that are going to tell us how much of each of these major compute resources that you go buy in the cloud do you actually need? So we got to figure out, how much are we actually using? Reasonable collection granularity is absolutely key. We had an environment a while back. They had a 32-core SQL server. The CPUs were maxing out at about 8%, and they swore everything was slow, nothing could be running great, and they're blaming the network. How they came to the conclusion that it was a network, I will never understand. We started digging into it. No exaggeration. 32 CPUs. 2 of them were at 100%. Everything else was idle. And somebody had changed the CPU affinity settings inside SQL Server. Why? Who? We don't know. But it was maxing out on the 2. So we fixed it and life went on. But that average got rid of the evidence there. So we want granularity on all the CPUs and all the disks and all the network adapters by name so we can actually get to this stuff. That GitHub repository has a number of queries out there that you can start to mine this information and actually see things like CPU consumption by core, memory usage on a SQL Server perspective, and not just the operating system that a lot of other tools go measure. Things like page life expectancy or memory grants pending, or different key metrics that we actually care about. And my personal favorite, storage IOPS and throughput. It's kind of like saying you got a super fast car in the driveway that's capable of 200 miles an hour. When was the last time you did that? Even though it might be capable of this, what if you're only going, 0 to 60 to go to the grocery store? Do you need all the speed? Maybe you want it, but do you need it? Because if you don't need it, you're still paying for it. CPU and memory allocations are really big. Having this ongoing rolling baseline is absolutely critical. This is an example, 18-core SQL Server. I ran Perfmon, captured some information for a week, came up with a chart that shows CPU consumption by core on a 5-minute average by core over a given day. Well, look at that. The metrics go up to 35% on 18 cores. Do we need all 18? No. Realistically, we dropped this down to 8 and it was still overkill. The price tag difference, both with SQL Server licensing on-prem and in the cloud, on a 10-core difference, it's pretty significant. Do you need everything that it's been allocated? When it comes to the resource allocation, there's a little bit of a difference between the virtual machine layer and the as a service layers. When you're looking at virtual machines, you select the series. So it could be CPU optimized or memory optimized or disk optimized. And then you select the amount of CPU and memory that you want for that given series. And then you attach managed disks. Now it's up to you. You have to understand how many, how fast, how big, What sort of caps are associated with the virtual machine itself and each virtual disk, and weigh this against what you're actually consuming today. You can see here that West US Windows operating system DS13 V2, 8 cores, 56 gigs of RAM, 112 gigs of temporary storage, a little over $4 US an hour. Not bad. That's a pretty serious machine. Now, if you're looking at database as a service or platform as a service, the vCore model is very different. It's honestly simpler. In this case, pick 8 virtual machine CPU cores. The memory just comes along with it. Configure the storage space, but storage speed and availability come along with the criticality tier. In this case, let's pick a terabyte, 256 US a month. Okay, that's pretty reasonable. Performance is not necessarily equivalent to price. How much of each of the major compute resources on these machines do you actually need? And I'm going to stress this over and over and over again. Assign the compute that you are actually consuming. You can always expand this thing as needed in the future. Don't pay more than you actually need. Save those cloud costs. Maintain the expected performance, and you have to have a way to go test your workload and make sure the performance is where you need it to be. Question number 7. How are you going to migrate your data? The migration strategies around getting your databases into the cloud are not always as simple as a backup and restore. This is one of those areas that I wish were easier. If you're migrating to a virtual machine, okay, yeah, this is pretty straightforward. You can do a backup and restore, you can do log shipping, you can detach and copy files up there and attach them, you can do database mirroring. There's a bunch of different options. These are all really things that we've done with traditional SQL servers for decades now. There is a service out from Microsoft related to the Azure Data Migration Assistant and Azure Data Migration Services that can actually attach to individual databases on-prem and replicate them out to the cloud on an ongoing basis. It will keep them in sync, and it makes your cutover window a whole lot smaller. It's pretty darn solid, honestly. If you're working on an Azure SQL managed instance, you can do the same backup and restore from a URL. You can actually back up and restore to an Azure Blob Store, and that's pretty solid as long as that meets your recovery goals. If the database is small enough, you can do a database backpack export and import. If you've never done one of these, play with it. It's honestly pretty cool because you can do just the schema with a DAC pack, or you can bring the data along with it as a backpack. The challenge there is if the database is pretty massive, you can end up with some really interesting file sizes that can get quite large very quickly. You can also use the Azure Data Migration Assistant or Azure Data Migration Services. The services are the things that will really keep this thing in sync. Basically bridges your on-prem environment to get to the cloud. It's pretty cool. If you're in an Azure SQL database, well, you get backpack exports and imports. You don't really have that traditional backup and restore mechanism anymore. Azure Data Migration Services is probably your best route to go here. Keep in mind that with whatever cloud service you're looking at, there are constraints in going out of that service. This also includes routine tasks like refreshing your databases from production to pre-production. Keep this in mind based on your tier, because a traditional backup restore from prod to pre-prod is one of those things that it may not work. So you may have to change your processes. I'm not telling you to not go there. You may have to change your processes in order to understand how to do this effectively, given that we need, different tiers for QA, UAT, developers, things like that. There are cloning options with any of these services out there. You can actually do different migrations out there. There are pieces where you can't do. Like you can't back up from an Azure SQL database to a regular SQL server. You can export and import, but you can't really do a traditional database backup anymore. You also can't back up from a managed instance to a regular SQL server. This is one of those areas that a lot of people don't really realize. It makes life more interesting. You can back up to another managed instance, no problem. But usually the metadata in the database is further ahead than the box product of SQL Server, since Microsoft has got a cloud-first model. And a lot of times we just can't guarantee that that restore is going to work. Data extraction and reloads is probably your best bet, but if the database is really big, well, you got to watch out for that. So it goes back to leveraging the features of that service and that tier to figure out, can we clone this thing? Can we do an instance level snapshot or whatever we need to do to get a copy of this elsewhere to do something with it. Question number 8. Have you validated your SQL Server licensing needs? SQL Server licensing is one of the most uncomfortable topics that I find with most organizations. A lot of times people are uncomfortable in talking about it because they may not understand the nuances that accompany their license. They also want to make sure that they're not accidentally out of license compliance. What a lot of people don't realize is that their SQL Server licensing entitles them to certain benefits in the cloud that allow for a pretty straightforward license migration or a transfer of licenses between different services that result in some cost savings. The single biggest question that I have for people, how are you currently licensed? And there are so many permutations of this. Could be SPLA licenses, could be EA, could be per core, could be server cal, could be standard, could be enterprise, could be all over the place. It's a really interesting discussion to take a really good look at what you've got and figure out what can we do in the cloud with the current licensing. What a lot of organizations really may not be aware of is that Azure hybrid benefits accompany software assurance with many of the licenses that they may already own. Azure Hybrid Benefits allows you to move your licenses to the cloud in about the most straightforward and pain-free method that you can possibly get. It does require software assurance. If you don't have software assurance in your on-prem environment today, I really wonder why. It does allow virtual machine mobility. There's a lot of good things that you get with it. I'm not going to preach on about that one, but it is something that you really need to consider, especially with new software purchases today. The cool part about this is that if you decide a given SQL Server is better suited on a managed instance or even just a couple of Azure SQL databases, these licenses could potentially be transferable between your on-prem servers and your target platform in the cloud. One additional benefit, especially lately in SQL Server 2019, there are specific disaster recovery licensing clauses that allow you to run an additional copy of your SQL Server in the cloud. And that's really, really cool because it might mean that you get your disaster recovery for a very limited or fractional cost from what you may have been already expecting to pay in the cloud or what you were paying for an on-prem DR facility. The biggest thing that I have is ahead of the migration so that you don't get surprised by any crazy bill. Run the numbers. It's not that difficult to get a good estimate for what you're actually looking at with your cloud migration. I cannot preach on this enough. Right-size your destination because it makes a massive difference based on what you consume versus what you allocate. The Azure Calculator will give you the ability to give estimates on the price if you bring your own license versus the included prices. This is a big deal, especially if you're dealing with a lot of machines, because this will give you a much tighter ability to project how much this is actually going to cost. Question number 9. Have you calculated the monthly cost of your cloud services and on-premises equivalent? One of the biggest cloud myths out there is that all of the cloud objects are pay by what you consume. This is one of the best deals of marketing that I've seen in a long time. And I'm not trying to discredit the cloud or any of the sales folks or marketing folks that deal with this. It's fantastic for them, but it's really tough for you. The analogy that a lot of these marketing materials actually make is specifically an analogy to the power company. The analogy is that you pay for the connection to your home, and then you're charged for the amount of power each month your family uses. Well, some things in the cloud fall by this model. Could be network throughput, could be DNS lookups, could be the amount of Azure Blob storage you actually consume for backup storage. But many of the things related to the Microsoft data platform, specifically SQL servers, do not adhere to this model. What they actually adhere to is to pay by what you allocate. This is a really big change from the marketing. The bulk of the SQL Server components out there, so SQL Server VMs, managed instances, some scenarios around databases as a service, definitely managed disk, all of these. If you provision, let's say, a $20,000 a month managed instance and then forget about it, well, you're still going to pay for that. How you use it is irrelevant at that point. It's really unfortunate. The allocation model is such that regardless of how you use a machine provision like this, you will be paying that estimated monthly cost. In this case, business critical, Gen 5, 8 cores, 256 gigs of storage. That's a significant cost per month. What if that workload would have worked just fine on 4 cores? Well, you could probably cut that cost in half. Do you really need all of those? This goes back to that baseline discussion that I have. Use the baseline that we've generated with Windows Perfmon and estimate the amount of CPU consumption that particular SQL Server is consuming. I want you to focus in on your peak and your business critical hours. Usually, it's a Monday to Friday organization. It's about 8 a.m. to 6 p.m., something like that. There could be peak times that are outside of these windows. They might be related to evening processes or integrity checks or database index maintenance, all these things that they might be time sensitive, but they might not. If they're not really that time sensitive and they're eating more CPU than what your machines are getting hit with during the day when it matters, when all your users are using them, is that something that you can kind of tone down its importance and really focus more in on the business critical hours side? Probably. It's up to you to determine your peak and critical hours that apply to your resource consumption baseline. Once you get that, then start to estimate out. Memory falls in line with this as well. It's not just CPU. How much RAM do you actually need? How low does your page life expectancy and memory grants pending sit during business hours? Is that something where you may need more? Can you get faster storage and insulate it? Does PLE crash when backups occur? Yeah, but is it okay after that? Probably. What do you actually need? Storage speed and storage space. All of these have to get factored in. How many IOPS are you consuming? How much space are you consuming? How fast are you consuming it? How much is it growing over time? Do I need to provision a virtual machine that has more virtual disks or a higher IOPS cap? All of these things matter based on your consumption rates. And it's up to you to determine this, because if you just throw a dart at a board, you may end up either undersizing it, which is going to kill your performance, or oversizing it, which is going to cost you too much. Bandwidth is another one. Even on a limited basis, we're sending a lot of data in and out of the systems. There could be a lot of traffic in and out with different ETL or data loads. Could also be a lot of traffic for backups in the evenings, however you normally manage it. It's something to keep an eye on. Usually it's a pretty small percentage of the overall cloud cost, but it is something to watch. Disaster recovery is another one there. Based on your SLAs for disaster recovery, both RPO and RTO, do you need a hot standby? Can you just get away with a backup vault and replicating database backups? What do you actually need? How much is that going to cost you to have that object either really hot and ready to go or in a nearline state where you can spin it up if needed? How much is that going to cost? Also, understand the amount of space that you need for backup retention, because a lot of times organizations in the cloud may want to take daily VM level backups for a month. How much is that going to stack up? How much space is that going to consume over time? Do they want to shift to a model where maybe after 3 weeks, then we go to a weekly snapshot and put it on an archival tier? Cost less, takes a little bit longer to recover it when needed, but you can still get it and keep it there for longer. The serverless model related to databases is one of those things that's fairly new. You may not have heard of this, but it's really cool. What it is a SQL Server environment, and in this case Azure SQL Database, that if it's not used for a certain period of time, can spin its compute resources either way down or just shut itself off. You still have to worry about the storage, and the next time you go to connect, then it'll spin right back up. This can save you some money because a lot of these systems may not be used at night or on the weekends, and your end result will cost you less. And that's cool because it might mean that in the times that you need it, you can get away with allocating more compute resources and making that piece faster, but just saving the cost at the end. The biggest way that I have to go estimate what your end of the month cost is going to be is the Azure Cost Calculator. It's located right here, completely free to use, wide open. It's got tons of permeations in there. In this case, we're going to look at a serverless Azure SQL database. Our backup storage tier is RAGRS Gen 5, general purpose tier. Number of cores, we're going with 4 cores peak, 1 core minimum. An average of about 2 cores used, 6 gigs of RAM total. And that's going to give us a price tag like this. Use this as much as you can. It's really helpful. You can actually rename the systems. You can save the quotes. You can import the quotes. I mean, it's really, really powerful. But this gives you the ability to project forward. What is that cloud bill going to cost? In order to use this effectively, you have to know what you want to deploy. Is it a SQL database? Is it a managed instance? Is it a virtual machine? Does your license come included with it? Are you using hybrid benefits? Are you looking at pay-as-you-go? Are you looking at a 1-year reserved price or even a 3-year reserved price? What works best for you and what works best for this particular system? Now, again, the licensing topic is never fun, but if you can bring it with you, it's going to save you some money. In this case, OS only, you've got the license ready to go, you just have to provide proof of it. Monthly cost is a fee. If you choose to bring SQL Server along with it, you can get a good projection of what the resource consumption is going to be if you choose to bundle your SQL Server license as part of your cloud bill and literally buy it with the virtual machine. You can do that really easily. Just change a type from OS only to SQL Standard or SQL Enterprise, and you can watch how your monthly costs are going to change. The sticker shock comes when you start to really look at this stuff. It's not a fun discussion because a lot of times organizations are used to a really big capital expense every 4 or 5 years for these different pieces, and then it really hits home when they have to pay this bill monthly. Come up with an equivalent cost of your on-premises data platform. This is an area that most organizations fail. There's a lot of work that has to be done to figure out how much that SQL Server costs you on a monthly basis. There's components like storage, physical machine, the licensing for the operating system, if you're running a hypervisor, if you're running any management or monitoring tools, the cost of the SQL Server licensing on there. But then there's more implicit, a little bit harder to figure out cost. What's the cost of the people managing the physical and virtual platform that you're running your SQL servers on? Can this be calculated by server? It can. You just got to be a little creative in how you put these numbers together. There's also the cost of the rack space. There's the cost of power, cooling, networking. All of this stuff you have to factor in. And when you run the numbers objectively, you might be surprised. I know you've got a big investment in your on-prem data platform. It's a pretty healthy one. If you're running into where everything is aging out, start to run these numbers very, very objectively. Simple spreadsheet. Take a look at your SQL Server. Take a look at putting together all of your different application servers. Put this into a 5-year cost model. Take the equivalent physical machine environment. Look at the physical machine cost. Look at the hypervisor licensing, if there is one. Primary storage in a SAN, backup storage, networking for servers, networking for your workstations. Look at firewalls. Look at your operating systems. Look at your SQL Server licensing. And this was just standard edition for just one VM. Look at your other software licensing. Look at the physical machine support costs. Any VARs, any vendors that need to go help out with this stuff. Figure out your expected hardware life for that investment. Put it side by side with the cost of the cloud for that platform and take a really good look at the objective differences between them. The other part is, in the platform that you have on-prem, how much headroom do you have in there versus how much headroom do you have in your cloud investment? The on-prem environment might give you more headroom, but if you're not using it, is it really there? And last, but certainly not least, question 10 is, what are your future needs? Today is as important as tomorrow, but tomorrow will help you understand, did we pick the right direction in this data platform when we went to the cloud? Did I make the right choice? What can I see coming from a business that could help steer the direction that I'm moving in the cloud? Easy ones to track. How much space am I consuming? Am I going to run into the threshold limits of one of the tiers that I'm deploying into, say Azure SQL Database or a SQL Managed Instance? What's coming in my business? I know 100% the pandemic this year has changed a lot of people's businesses, probably not for the better. What do you foresee changing in your business? What can we get in front of? Could be, your business is about to buy another one. Could be you might be laying some people off. Could be you're about to take a whole new line of product or sales or services. What's going to change that you can anticipate at least? What upcoming projects? What new software is your company looking to acquire and adopt? What about DR? Are you looking to improve anything that you've currently got? Another big one that a lot of people really don't even want to think about: what kind of scalability limits do you have in your current application or database design that, while they may work fine now, what happens if your user volume goes up? How bad of a position is that going to be in if these things get in the way of being able to scale and have these systems reach into the space that they need to for your business? What can you do with the cloud to help you modernize these limits and work through them? What kind of known limitations or flaws do you have in your systems? What can we do to get in front of that? And I know these are loaded questions. These are hard. A lot of these things we can't think of. But what can we do? What do we know today that maybe we can embrace a new feature in the cloud or go to a different platform and literally just throw away one of the known problems that's dependent on an operating system or things like that? Or what small things can we change to help get onto some of these newer platforms so that we have more time to focus on the proactive nature of what we do? And then a bigger thing, will your vendor even support it? What kind of vendor lock-in do you have with certain practices, certain patterns, certain choices that they've made that require that you go with a VM or even stay on-prem? We've got a handful of customers that have a particular manufacturing app. It is not very friendly. They do really silly things like when you place an order, it fires agent jobs. Well, no SQL database for that one. There's nothing we can do about it. And the way they fire it also means we can't use a managed instance. They are stuck with IaaS. What are you doing to plan for any of the changes that you're aware of that either will happen or need to happen? What are you doing for this today? What can you think of tomorrow to get in front of these things? To wrap the session up, the biggest single thing that I want you to stress about is that the cloud is a fantastic tool when it's the right use case. It's not the only tool in your toolbox. I really want to stress that. Cloud is not a fad, it's not a cool kids club, and it does require a significant change in the way you use your data platform. Migrate your data to the cloud platforms for legitimate reasons, but choose your path wisely, because if you go down the wrong path, it can be very difficult to back out of that path to proceed in the correct direction. As I mentioned before, the single biggest change with the cloud is the financial model. So understand your cost model for your proposed cloud services, but make sure you have an equivalent cost model for your on-premises environment so you can have an objective comparison. I want to thank all of you for taking the time out of your day to watch this session. Hopefully you learned a little bit about what questions to ask related to your organization's cloud migration. If you have any follow-up questions after the summit wraps up, please don't hesitate to reach out to me at any of the means below, and we will find a time to chat so we can answer any and all of the questions that you may have. Thank you.